Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Dutch Arrows by Michael Lefkowitz. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Excuse me. We have Dutch arrows, where a digit on an orange arrow indicates how many cells in the indicated direction differ from it by at least 4. So let's use this as an example. Say we had 3 here. Then 3 of the digits on this indicated direction are at least 4, differ from it by at least 4. So you could have something like, I don't know, 7, or maybe don't make it there. We could have 7, 8, 2, and 7. And this would be valid because along this diagonal, we have 3 digits here, which differ from it by at least 4. And those are all the rules. If you'd like to play, I was thinking through what the implications of that are. Interesting. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this has 2 digits at most that are going to be 4 away from it. So this is 1 or 2. This has 3. So we have 1, 2, or 3. This has 4, 1 through 4, 1 through 5. Okay. This can see 1, 2, 3, 4, 5. But the problem, if this is 5, is that there's only 2 digits which are 4 or more away from it at all, which is 1 and 9. And you can't have more than 2 1s and 9s in a column. So this can never be... You can't have 5 here. You can't have 4 here for the same reasoning. 4 can only be next to 2 unique... which have... 4 can only have 2 unique digits, which are 4 or more away from it, 8 and 9. So 4 doesn't work. So this must be 1, 2, or 3. Similarly, 6 cannot be here, right? 6 only has 2 digits that are 4 or more away from it in column. So that never satisfies that. You have the same problem with 5 and 4. So this is also 1, 2, or 3. So any row or column, that works. This has 1, 2, 3, 4. So this is 1 through 4. But this digit is not going to be 5 or more, 4 or more away from 4. Right? 1 through 5 is not 4 or more away from 4, so this has to be 1, 2, or 3. This digit is not going to be 4 or more away from this digit here if this were 5, so this can't be 5. This sees 1, 2, 3, 4, 5. So this could be 5 that are 4 or more away from it. But again, 1, 2, and 3 are not going to be 4 or more away from 5 or 4. So this is 1, 2, or 3. This could be 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, or 7. And this is 1, 2, 3, 4, 5, 6. This could be a 1-2 pair all the way through, so that is possible to be 6. This could be 1-9 pairs for 5 of them, and that would still be possible. This is 1 through 7. 7 would require 1, 2, and 3, which is also feasible. Unlikely, but feasible. So one of these is guaranteed to be a 4. That's interesting. This cannot have 4 because 1, 2, and 3 is never going to be 4 or more away from 4. So this has to be 4 here because of the 1, 2, 3 triplet in the box. So these must be 4 or more away from 4, which makes this 8 and 9 as a pair. These are going to be 4 or more away from 1, 2, or 3. So this can't be 1. This is at least 2 and 3. Remaining digits of box 6 are 5 through 9. This is 1, 2, 3 as a triplet. So 3 has to be one of these. This is obviously not going to work, but 3 could have... If you try to have 3 here, this is not 4 or more away from 3. This would have to be 7, 8, and 9 as a triplet, but because those are the only digits 4 or more away from 3, but that would eliminate all possibilities for this cell here. So this cannot be 3, which means 3 has to be here. This obviously can't be 3. This has only 2, or these 2 digits, so are guaranteed to be 4 or more away from 1. So this cannot be 1. This has to be 2. 3 has to have 7, 8, and 9, 4 or more away from it. So this is 7, 8, and 9. 2 cannot, this is 3, 2, this must be 1, which makes this 2. 2 can only have 2 digits, 4 or more away from it in this direction. And this can't be 2 here. So, 2 can be next to 6, 7, 8, or 9. Or can have the only digits 4 or more away from 2 are 6, 7, 8, or 9. So we can only have 2 of them here. We must have the other 2 in these sets here. 2 eliminates 2 here, so this is 3. So this has to be, this can't be 4 more away from 3. So this has to be 7, 8, or 9 here to be 4 more away from there. So this 3 satisfies these. This 4 is these 4. This 3 is these 3. 2 is here, so this has to be 2 or more away from, 4 or more away from 2. Cannot be 1, 3, 4, or 5. It's 6. So these have to be 4 or more away from 6, which can only be 1 or 2. 2 eliminates 2 here, so that's 1. 2 eliminates 2 here, so that's 1, which makes that 2. This is 1, 2 as a pair, which eliminates 1 and 2 in the rest of the box. So this can't be 1 or 2, it's 3. This can't be 3, it's 1 or 2. This 3 eliminates 3 here. So this guarantees 7, 8, and 9 are seen here. So this cannot be 7, 8, or 9. Cannot be 1, 2, or 3. So this must be 4, 5, and 6 here. So that means this must be 7, 8, 9 here. This can't be 6 because of 6 in the row. These are not... This cannot be 1, 2, 3, or 4. So this is 5 through 9 here. This is 1, 2 as a pair. Remaining digits of column. 6 eliminates 6 here. Remaining digits of column 8 are 5 through 9. So no 6 here because of 6 in the box. 2, 6 away. This has to be, cannot be 7, 8, or 9 because of the 7, 8, 9 triplet in the box. So this has to be 6 because it's 4 more away from 2. Remaining digits of row 7 are 4 through 9. No 6 here because of 6 in the column. We are guaranteed 2 digits out of 7, 8, or 9 have to be here because 6 can't be here. And this is 7, 8, or 9, so this cannot be 7, 8, or 9, or 6. So this is 1, 3, 4, 5. This is guaranteed to be 4 or more away from 1. But we don't have any other information. This is not 4 or more away from 4, 5, or 6. So this cannot be 6 here. It's 4, 5. We're guaranteed a 6 here. We're guaranteed a 6 here. This cannot be 1. If it's 1, we already have this is guaranteed to be at least 5. This is guaranteed to be at least 5, and both of them are 4 or more away from 1. 6 has to be one of these 3 digits here. And this can't be 6 because of the 6 guaranteed here. Can this be... 5 would have to have 1 and 9 continuously on this diagonal. So this would be 1, 9 if that were the case. It's possible. 4... Huh. 4 can only be 4 away from 7, or 8 and 9. This is guaranteed not to be away from 8 or 9. So this would have to be 8, 9, 8, 9, 8, 9, 8, 9. So this cannot ever be 7, which means where's 7 in box 2? It must be here. That eliminates 7 from the rest of the column and 7 from the row. Remaining digits in... Where's 2 in box 2? It has to be here. That leaves this as a 4, 5 pair. 2 eliminates 2 here, so that's 1. So we only have 1 digit along this diagonal, which is 4 or more away from 1. And it has to be that one. So these have to be 1 through 4. So this is 3 or 4. This can't be 2. It's 1, 3, or 4 here. 1 eliminates 1 here, so this is 2, which makes this 1. 1 has to be one of these 2 digits here. So again, if this is 5, this would be 1, 9. We have an 8, 9 pair, actually, in column 6, which eliminates 8 and 9 in the rest of the column. No 6 here either, because of 6 in the column. Remaining digits of column 5 are 4, 5, 6, 8, and 9. Okay. So let's figure out which are satisfied. This is satisfied. This is satisfied. 3 is satisfied. 4 is satisfied. 1. Okay, so 1 cannot be 2, 1, 2. So therefore, none of these are already 4 or more away from 1. So this must be. So this is 5, which makes that 4. 5 eliminates 5 in the rest of the row. So now we have an 8 and 9 pair in row 1. That's interesting. So this is satisfied. 3 is next to 7, 8, or 9. That's satisfied. 8, 9 as a pair eliminates 8 and 9 here. Remaining digits of row 1 are 1 through 4. No 2 here. We have a 1, 3, 4 triplet in box 3, which eliminates 1, 3, 4 in the rest of the box. So this is 5, 7, 8, 9. Remaining digits in row 3 are 5, 6, 7, 8, 9. No 6 here. 2 eliminates 2 from being here. Remaining digits of row 2 have to be 1, 3, 4, 5, 7. And this can't be 1 or... this can't be 3. 2 eliminates 2 here. Where is 2 in box 1. It has to be here. So that's 2. 2 cannot be either of these, which means 2 has to be here, which makes 1 there. Which means 1 cannot be either of these. So where's 1 in box 1? It can only be here. So this is 1, which eliminates 1 here. 3 here is satisfied. This is 1. That's satisfied. 3 has 7, 8, and 9 here. Remaining digits of column. So it could be 4, 5, 7, 8, 9. Okay. 3 is satisfied here. 4 does not work. Because if 4 is here, 1 and 3 and this digit are not going to be 4 or more away from it. So this has to be 5. Which means this is 1 and 9. This is 9. This is 9 and 1. And that's satisfied then. So this is satisfied. This cannot be 5. There's no 5 here. 9 eliminates 9 here, so that's 8 and 9. 9 eliminates 9 here, so that's 8. 9 eliminates 9 here, so that's 8. No 8 or 9 here. No 8 here. 9 eliminates 9 here. No 8 or 9 there. 9 eliminates 9 here and here. No 5 remaining in row 7. No 9 remaining in column 8. Remaining digits of row 4 are 4, 5, 6, 7. No 5 here because of 5 in the column. No 8 and 9 in box 5. Remaining digits of column 4 are 3, 6, and 7. Okay. Can this be 7 here? No, because 5 and 6 is not 4 or more away from 7. And all of these would have to be if this is 7, obviously. Can this ever be 4? This is not 4 or more away. This could be. No, 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 no. And that's already 3. At most. That's 4 or more away from 4. So this cannot be 4. This is 3, which makes this 4. No 3 or 4 here. This is 5, 7 as a pair, which eliminates 5 and 7 in the rest of the box. So it can't be 5 or 7. 3 makes this not 3, so this is 4. This can't be 1 or 4. It's 3. That leaves 1 and 2 remaining in column 9. So this can't be 1 because of 1 in the row. So this is 2. That's 1. So this has 3 digits, which are 4 or more away from 3. We have 3 in the corner. We celebrate that. Does that help? I don't really know. 5 is done. 3 is not quite done. So you could have 7 here. You could have 9 there. This is not. This is not. So let's just mark those. 2 is essentially done. We have a 7, 8 here and a 6, which leaves 6, the other 7, 8, and the 9. 9 eliminates 9 here, so this is 8. No 8 or 9 here. No 8 here, no 8 here. 8 eliminates 8 here, so that's 7, which makes this 5, which makes that 8. 5 eliminates 5 here, so it's 7 and 5. That means this can't be 5 here. This can't be 4, 5. It's 7. So no 7 here, no 7 here. 7 eliminates 7 from being here. This is an 8, 9 pair, which eliminates 8 and 9 in the rest of the box and column. So this can't be 8 or 9, it's 7. This can't be 9, it's 6, which makes this 9. 6 is not 4 or more away from 3. Neither is 2 or 5. 6, 7 is. So we have 2 more out of these 3. Okay. 8 eliminates 8 from being here. Remaining digits. 7 eliminates 7 from being here. Remaining digits of column 7 are 1, 3, 4, 5, 9. Interesting. 7 eliminates 7 here. No 7 here. Hmm. 6 and 4 eliminate 4 and 6 here, so this is 5, which makes this 6, which makes that 4. So no 6 here. 8 eliminates 8 here, and one of these is guaranteed to be 7, so this can't be 7 here. It's 9, which makes this 4, which makes that 7. No 4 or 9 here, no 7 here. 9 eliminates 9 here. This is 5, 7 as a pair, which eliminates 5, 7 in the rest of the box. No 5 here, so that's 9. 7 is 4 or more away from 3, so that's satisfied. This cannot be 4 or 9, so this has to be 3 and 5, which eliminates 3 and 5 in the rest of the box. This 3 or 5 is not 4 or more away from 3, so therefore this must be here, and this must be an 8 then, which means the 3 is satisfied. So the rest is probably just normal Sudoku. 8 eliminates 8 here, so it's 6, which makes this 7. 6 eliminates 6 here, so it's 8, which means this can't be 8 here. 8 eliminates 8 here, so that's 9 and 8. 9 eliminates 9 here. We have a 3, 4, 5, 6 quadruplet in row 9, which eliminates 3, 4, 5, 6 in the rest of the row. So this is 2. That should give us all the 2s. Remaining digits in column 6 are 3, 4, and 5. 7 eliminates 7 here. Where is the 9? It has to be there. Okay, remaining digit in column 2 is a 3. So 3 eliminates 3 here, so that's 4. No 4 in the rest of the box. This is 5, 6 as a pair, which eliminates 5, 6 in the rest of the column and box. This is 4. No 5 here, it's 3. No 3 or 6 here, it's 7, which makes this 5, which makes that 7. 5 eliminates 5 here, so it's 6 and 5. This can't be 3 or 4. It's 5, which makes this 3, which makes that 5. 3 eliminates 3 here, so it's 6 and 3. 4 eliminates 4 here, so it's 6 and 4, which leaves this as a 6 and this as an 8. And that's solution. Pretty interesting, actually. I wanted to see how, like, this is the first time I've seen this type of rule set, so I just wanted to try it out. Definitely potential for other set puzzles, right? Because it's not that restrictive as I thought it would be. Well, in some cases, in some ways it is. In some ways it's not. So it's kind of interesting, though. Yeah, anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.